Okay, so let's now start our discussion of circles. So first let's discuss about what is chord and what is a secant when we discuss about circles. So chord is a line passing through 2 points on the circle. Any 2 points lying on the circle, and if they are joining each other and they will be forming a line, that will be known as chord. A diameter is the largest chord. The difference is that there is center, the diameter is passing through center. If we discuss about secant, secant is just a chord which is extended to in one of its part or both of its part. So secant can be like this, or a secant, this can also be called as secant. It is just that the line is extending outside the area of the circle. Are these two things clear?
Yes, sir.
Let's now discuss about tangent. So let me use drawing this time. There's a circle, and the line is passing in such a manner that the line is not touching in two parts, in on 2 points, or it is touching just on a single point on the circle, on a single point. This line, then it will be called as tangent. It is only touching the circle at one point. Now let's discuss about some properties of the tangent. That the tangent, if we join the center and the tangent's intersection point, then the angle between the radius adjoining the center and the point of intersection and the tangent will always be 90 degrees. This is 90 degrees. So this is center, this is a tangent. As you know, this is a line. So its equation will be even, let's say, even x plus b1y plus c is equals to 0. Okay. And let's call it as a, b only. So ax plus by plus c is equals to 0. It is the equation of this line. And c is the center. Okay. Let's say the center's point is h and k. If we have to find out the radius, okay, then the radius here will be equal to the distance between the point C, and let's call this point as T, the point of intersection between the circle and the tangent, CT. So the distance, so the radius here is equal to the distance between these 2 points, center and the tangent. And this can also be found out by using the distance formula if we know the coordinates. If we do not know the coordinate of t, what we can, if we know the only the point in the equation of line, then we can use the formula of finding out the distance between a point and a line, which was, if you remember, uh, to find out the distance between a point and a line, we refer to the perpendicular distance, which is the shortest distance. Okay, and in this case, the perpendicular distance will be radius. How we'll find out? We'll simply substitute x and y with the point h and k plus c divided by a square plus b square. That will be your distance. So basically, that's just an application. I'm not asking you to cram it, but it will be safe for you to understand it, so that we are going to now further on discuss its more application. So the point, my gist of the point is that the distance between the center and the center, which is a point, and the distance between this line, can we find it out by this method as well? And this distance is going to become the radius of our circle. Is this clear?
Yes, sir.
Yeah. Whenever you have to have dinner, then please tell me, okay?
Yes, sir.
And now let's talk about the intersection of line and the circle. We discussed about it earlier that if the line is intersecting at 2 points with the circle, then it's a chord or a secant. If the line is intersecting with the circle at only 1 point, then the line is a tangent. And tangent behave in a certain manner. Okay, so this is the equation of line y is equals to mx plus c, and this is the equation of circle. Now see, the equation of circle is interesting. The center is 0, 0 here, and the radius is r. And m is the slope, and c is the intercept. Okay. These are the equation of line and circles. Now, when we are talking about the intersection, so whenever we have to solve for the intersection point or points, we just solve for the common y and x, and then we come to have some equation by which we can get the value of y or x. So we have y is equals to mx plus c from the equation of line, and from the equation of circle, x square plus y square is equals to r square. Now I'll substitute the value of y in the second equation. So here in this equation, we can see that the general, like if we take the general coordinates, then only x is there in the equation. There's no y. So if we consider this equation, we'll expand it further. Then this equation will take this form: 1 plus m square into x square plus 2mcx plus. So here we can see that this is a quadratic in x. This is a constant. Ax square plus bx plus c. This is a quadratic simply. So if this is a quadratic, we can know about x point. We know that whatever x we are solving for is the intersecting point between the line and the circle. So if there is some real root for x, that means the line, the circle is intersecting. If there are no real roots for x, that means that the line and circle are not intersecting. Okay, so to find out whether, and even if like whether to find out there are roots existing, two roots, real roots or unreal roots, we will find out simply what discriminant. So discriminant here in this case is this r square into 1 plus m square minus c square. Okay, this is the discriminant. So we know if discriminant is more than 0, that means roots are real and distinct. Means there will be two real roots. If there are two real roots, means there are two intersecting points. If there are two intersecting points, that means the line is intersecting a circle, 2 points. It can be a secant or whatever. So for this condition, if we solve it further, discriminant is r square into 1 plus m square minus of c square should be greater than 0. We solve it further, taking c square onto that side, finding out r from here. So square root of c is c on 1 plus m square square. So if radius, so this is the condition that becomes that if r, the radius of the circle is greater than the c upon 1 plus m square root, then our circle, then the line is going to intersect the circle at two distant points. Now it will be, I know this is a little bit harder for you to remember. So let me give you an easy way to understand it. So what we had a circle with equation x square plus y square plus is equals to r square. Means the origin, means the circle center was at origin. Okay. So the circle center is at origin. And the radius is r. The radius is r. Now we know a formula for finding out the distance between the circle and the line. So let me draw a random line, and its equation is y is equals to mx plus c. Now writing the equation of line in our general basic form. Okay, how do we find out? Now let's find out the distance of the line from the origin. Why are we finding out? I'll tell you later. First, let's consider this is the center, and this is the line's equation, right? So the distance between the line and the circle will be given by, let me call it as d, will be given by m, in substituting the point y is 0 plus c mod divided by coefficient of x plus coefficient of y whole square, which is minus 1 whole square is 1 only. So the distance comes out as c divided by square root of m square plus 1. Now see, this is the distance between the line and the origin. Okay. If it becomes, if the distance between this the center and this line is equal to radius, means this line is going to touch, means the line is touching the circle at one point. If d is equals to r, it means the line is just touching the circle at one point. If so, in this case, the radius is equals to the distance between the line and the circle. So d becomes here c upon m square plus 1. Okay. So this is the distance between the line and the center. If it becomes less than r, if the distance becomes less than r, means we have a line that is somewhat nearer. The perpendicular distance between this line and the center is less than r. So it means that radius is greater this time than the distance between the line and the center. If the line is outside the circle, not touching anyway, then this time the perpendicular distance between the center and the line is greater. R is less than C upon square plus 1. So if R is becoming equal now to the distance between the center and the line, then it means the line is tangent. So this is another one way to understand that how we can remember R is equals to how we can relate R and the distance between the line and the circle. Sorry, the line and the point and the center of the circle. So here in the first case, when we are looking that the distance between the center and the circle is less than r, it means that the line is existing somewhat inside the circle and it will be intersecting at two distinct points. So is the case one clear? Is the case one clear? Yalini,
Yes, sir.
please respond. In case two, when the distance between the point and the line becomes equal to the radius, that means the circle will be touching the line at only one point. At only one point. So that means the line is tangent. So this is the condition for tangency. Very important. And in third case, when the distance between the center of the circle and the line becomes more than the radius, that means simply the line is lying outside the circle. out of its reach. So this is the condition for that. And now it will be easy for you to remember the right hand side as it is the distance between center of circle, which is 0, 0 with from line. It is also written here. The length of perpendicular from 0, 0, which is the center here, on equation on this line is given by c by square root of 1 plus m square. But I have explained also that how it is written. Now, is this thing clear?
Yes, sir.
So see, here the condition of tangency is given. If the line y is equals to mx plus c touches the circle. Touches the circle means touches the circle at one point, means it is a tangent. Then this is the equation of the circle is this, equation of line is this. Then if and only if means this will be tangent if and only if when the intercept is equals to plus minus r square root of into square root of 1 plus m square. So it is another way to write c by if and only if. And c, there is a modulus here. Okay, there's a modulus here. So c can be plus minus. That's why there is plus minus written. That's one condition. Another one is that the line Lx plus my plus n will touch the circle. This is the equation of circle. Now see, what is the, this is the another condition. L square plus m square. So from here, if we understand, what is the center of the circle? Minus of g, minus of f. Okay. So the distance between the center and the line which is Lx plus my plus n equals to 0. So in place of x, I write this. In place of m, I write minus of f plus of n modulus divided by square root of L square plus m square. This has to become equals to r for becoming a tangent. Okay. So what was r? What is r? R is from the equation of circle. I can write r is square root of g square plus f square minus of c. Yes, that's what it is. So let me write radius here. Square root of g square plus f square minus c. Now taking square on both sides. Is equals to minus of Lg minus of mf plus n square. So this becomes the condition. This has come out from the same concept only. Okay. These are two conditions. This time the equation of circle was given in this very simple format where the center was at origin. This time the circle, this is the generally condition we can call it. Okay, you don't have to remember it. Just remember the concept. Very important. Now, discussing about this point, the line y is equals to mx plus minus r is always a tangent to the circle. Why? This is the equation of circle. And why this is tangent? Because if we see y is equals to mx plus c, then c's point, c, this is the condition only now. They have replaced c with this. So this is hence the equation of tangent. This is the equation of tangent. Okay. Any doubts in understanding the concept that I've written here?
No, sir.
Okay. Now, it is never asked, it has never been asked in your exams, but still, let's discuss it. The equation of tangent when the when the circle's equation is given. So it is a simple factor. The equation of tangent is equals to 0, t is equals to 0. And what you have to do, whatever equation of circle is given to you, whatever equation of circle is given, just do this thing. This is a trick. Replace x square with x1, y square with y1, and x with x plus x1 by 2, and y, replace y with y plus y1 divided by 2. And the constant remains unchanged. Constant remains like constant. So let's take an example. So if there is an equation of circle given like this, x square plus y square plus 2gx plus 2fy plus c is equals to 0. If this is the equation of circle, then the equation of tangent will be given x square x1, y square will be y1, 2gx x plus x1 divided by 2 plus 2f, y plus y1 divided by 2, c remains c, 2 cancels 2, 2 cancels 2, so it becomes x1 plus y1 plus 2g x plus x1 plus, no, 2 is already cancelled, no? Plus f into y plus y plus y1 plus c is equals to 0. So this is the equation of tangent. This is how we can find out the equation of tangent. Clear?
Yes, sir.
So what you have to remember? You have to remember this condition very well. This condition. Okay. And if this is the condition as we discussed, that y is equals to mx plus c is the equation of straight line, and x square plus y square is equals to r square. This is the equation of circle. Then the equation of tangent plus minus COs plus minus a into square root of 1 plus m square. Okay, let's confirm. Yes, that was it. Wait, it was r, not a. So, like I have remember a as the radius, so r is the radius, not a. So, this is the equation of tangent, where c is this. The point of contact. Point of contact means this is the radius, this is the circle, and this is the tangent. This is the point of contact. This will be given by minus plus a square m, not a square m, r square m. We are writing r for the radius, that's why. By c, and less minus, plus this time, minus this time, r square by c. This is the point of contact. You can also find out after like solving for if y is equals to mx plus c. From by solving from these two equations, this has been found out. Understood?
Yes, sir.
See, the question, the chapter has a lot of concepts, lot of topics, but when you start solving the questions, you'll find that questions has been asked on the condition of tangency, and basically the distance between the center and the line, and simple questions from general equation of circle. That is all from where questions has been asked. And also one more topic, that is the length of tangent. And why, like that can be find it out by simply remembering one formula. Let's discuss this example. So here we have to find out the range of values of n for which the line y is equals to mx plus 2 cuts the circle x square plus y square is equals to 1 at distinct on coincident points, basically distinct points. So means the line is cutting the circle at two different points. Distinct means two different points. Okay, that is so. First, what we need to find out is, first it is very clear that the distance between the center and the line is less than the radius. Okay, how can the distance be given? Distance was given by c divided by 1 plus m square less than r. R is actually here, 1 here. What is c? C is y is equals to mx plus c. So c is 2 here. M is m only. M is m only. Cross multiply this completed. Now what we have to find out? The range of values of n for which actually m, this is a misprint. There's nothing like m here. You have to find the range of values for m. Okay, so how can this be solved further? We will take square on both sides. Okay, now 4 minus 1 becomes 3 m square. Now it can be rewritten as 0 is equals to m square minus 3. It can be rewritten as 0 m square minus root 3 whole square. So 0 m plus root 3 into m minus root 3. So minus root 3 and plus root 3 plus infinite minus infinite wavy curve method. The coefficient of both of the variables is positive here. So this is going to be positive, negative, positive. What do we want? We want the function to be more than 0. So means m will be lying from minus infinity to minus root 3 and then plus root 3 and then 2 plus infinity. So let's see if this is, yes, this is in the first equation. This is in the first option. Now see one thing. At distinct, it should be R. Yeah. There are a lot of misprints. Distinct or coincident points. So the coincident situation will be inculcated. We'll take D is equals to R. Then the line becomes a tangent. Okay. If we inculcate quality also, then this point will also be included. This point will also be included. There will be a square bracket here, square bracket here. But still small bracket with the infinity, because infinity is never included. There's another misprint in the book. Here should be small brackets. Is this thing clear?
Yes, sir.
Now another very important topic is the solution. Another very important topic is that length of tangent. Length of tangent. What do you mean by length of tangent? Because we are not able to find out the length of whole uh, line, because a line extends to infinity. But what it means from here, that if there is a point on the tangent, how do we find out the length between P and T? Okay. So for doing so, what we'll have to do? This is the given equation of straight line S. Okay. So in S, there is a function, equate that to 0. Then, sorry, function, there's a function there's a bivariate function in X and Y. Now, substitute X and Y with the point that we need to find out now. X1 and Y1. And then take its square root. This is simply the distance. Or we call it as length of tangent. So this was the equation of circle. We have made this made a right hand side as 0. In the left hand side, substitute x for xy, x1 and y with y1 and then take its square root. This is the length of tangent. As simple as that. What is this? PT. Okay. This is the length between PT. And we also remember one more point, that this distance and this distance, PT and PT dash are equal. Just for revision, this is a theorem from class 10th. PT and PT dash are of same length. Is this point clear? Let's take an example. Okay. I repeat that these type of questions are repeated in previous years. The length of tangent drawn from the point this to this circle. So first we will do is to make right hand side 0. Done. Now we'll replace x with -1, y with 4. And we'll take its square root. This will be the answer. Okay. So this becomes 2 plus 4 square, 16 into 32 minus 19 minus 9. 34 minus 9 becomes 25, I guess. Yes. Square root of 25 becomes 5. So this becomes the length. Okay. I'm doing one mistake. Uh, Actually, no. That we are doing here is not finding the equation of circle rightly. So this is not how we write the equation of circle. Why? Because the coefficients of x square and y square has to become 1. So we have divided both sides by 0. So sorry, both sides by 2. So now when the coefficient of x square and y square are equal to 1, then we'll substitute x with minus y and y with 4 and minus 9 by 2 and square root. This will be the length. 1 square root 4 square is 16 and minus 9 by 2. 17 minus 9 by 2. So 34 minus 9 divided by 2. That becomes 25 by 2. That becomes square root 25. Square root of 25 is 5. Square root of root 2 is root 2. 5 by root 2 units. So please take care of the small mistakes to convert the general equation of circle into the equation of circle in which the coefficient of x square and y square are equal to 1. देखो यहाँ पे the coefficient of x square and y square were equal to 1. Understood?
Yes, sir.
Okay. When the circles will intersect at right angles, means that they're if like the tangents circles first, this point should be clear. And when the circles will be called orthogonal, the condition for them is to simply, if there's let's say s1 is equals to 0, this is the equation of first circle. S2 is equals to 0, this is the equation of second circle. Then s1, let me write it as ax square plus by square plus 2g x square plus y square plus 2gx plus 2fy plus c. And let's take one c1. This is the equation of first circle, equation of second circle. So the condition of orthogonality say that 2 into G1, G2 plus F1, F2 should be equals to C1 plus C2. You have to memorize it. G1, F1, sorry, minus of G1 and minus of F1. This is the center of first circle. Minus of G2 and minus of F2 is the center of second circle. C1, C2 are constants. Let's take an example. If the circles of same radius A centers at this and this, okay, the condition was 2 into G1, G2 plus F1, F2 to become C1 is equals to C2. Centers we have, radius is same. So now there is a challenge to find about C. Okay. So this time we'll have to solve for, okay, if the circles of the same radius A and centers, okay, what we need to find out is the radius. We need to find out for the radius. Okay, so G1 is minus of 2 into minus of 5 plus minus of 3 into minus of 6 is equals to C1 plus C2. So this becomes 10, this becomes 18. 10 plus 18 becomes 28 into 2, which is 56 is equals to C1 plus C2. Okay, let's keep this data. We'll use it whenever we'll need it. Okay, so let's draw the drawing of those two circles. Let's say this is a circle 1, and the circle 2 will also be of the same size because the radius is same, and they are cutting orthogonally, so this should be their diagram. Okay, let's meet their radius. Let me join their radius, their radii. Okay, now their radius is the same, so this is also radius, this is another radius. Radius is A. The centers are 2, 3, 5, 6. Let me call this center as center 1, center 2, this point as P. So one thing that is very unique here is that from the conditions that we are going to discuss now, the condition that we are going to discuss about two circles intersecting each other. From there, we conclude that the distance between C1 and C2 whole square is equals to PC1 whole square plus PC2 whole square. Why it is so? Because the circles are orthogonal, means this is 90 degrees. Why? Because the centers are cutting each other orthogonal. So the point of intersection, the radii will be making a 90-degree angle. Okay, if that is so, then this becomes perpendicular and hypotenuse base, and this becomes the hypotenuse. So C1, C2 should be square root, should be like the hypotenuse, and that's why this is a Pythagoras theorem. Okay. Now, how should we find out C1, C2? Because we know the coordinates, so it is very easy for us to find out using a distance formula. It is a square, so square root and square will be cancelled. 5 minus 2 whole square, which will be 3 square, which is 9. 6 minus 3 whole square, which is again 9. PC1 is a square plus a square, makes itself as 2a square, which is equals to 9 plus 9, which is 18 now. 18 by 2 is equals to a square. This becomes 9. A square comes out as 9. A becomes plus minus 3. Now, the radius cannot be minus. So, a is equals to plus 3. Yes, radius is plus 3. Understood? Any doubts? Should I explain it again?
No doubt,
The
sir.
only, yeah, only the only breaking information was that the circles was cutting itself at 90 degree. So it means the radii the radii at the point of intersection at both circles will be making 90 degrees angle. See here, 90 degrees angle. Now let's discuss about the family of circles. Family of circles means when we'll have more than one circle. So we have general equation of a circle, as we know, x square plus y square. Coefficient of x square and y square are 1 plus 2gx plus 2fy plus c is equals to 0. Then family of circle passing through the points of intersection, passing through the points of intersection of line. Equation of line is given, and the equation of circle is given. So the family of circles means all the circles that will be passing through the circle and the point of intersection that will be passing through the point of intersection of the line and the circle will be given by this equation. X plus lambda p is equals to 0. S plus lambda p is equals to 0, where S is the equation of straight line, equation of circle, and we are only considering the left part of the equation. And P is the equation of line, and we are only considering the right part, so the left part of the equation, which is Lx plus m by plus n. Okay, so if we write it after expansion, it is written somewhat like this. And then onto the right hand side, this is equals to 0 plus lambda into 0 is equal to 0. So the right hand side remains as 0 only. Okay. Okay. Now this is somewhat the same for the circles as well. There are two circles. Then all the family of circles passing through the point of intersection of two given circle will be given by this, where lambda is any scalar constant. And the equation of family of circles passing through the 2 points. This time this is something unique. That the equation of family of circles passing through 2 points, any 2 points, it will be given by x minus x1. So this is basically the equation of circle with diameter extreme points as x1, y1 and y1, sorry, x2, y2 plus lambda into the determinant of this x1 by x y1. This is basically, if I can recall it correctly, this is the equation of line passing through 2 points. Please read it for a second and give me a minute. Okay, let's do one example. Okay, so we have two circles, and the equation of we have to find out the equation of the circle, which is passing through the intersection of these two circles and also passing through another point. Okay, first let's focus on these two circles. We know that if I call this as S1 and this is S2, so the equation of the circle passing through both of these circles will be given by S1 plus lambda S2, which is actually the equation. And if we write it, then it becomes equals to 0 as well. Okay, then. So x square plus y square minus of 8x minus of 2y plus 7 plus lambda x square plus lambda y square minus 4 lambda x plus 10 lambda y plus 8 lambda is equals to 0. Now this is the equation of new circle that is passing through, like all of the circles that are passing through these intersection of these two circles. Okay, great. Now we know this that we have to particularly find out the equation of that circle which is passing through this point as well. So if this is the equation of all those circles, if we substitute with -1, -2 for x, so this is going to be definitely satisfying this equation. But we know there is a lambda which will be remaining on one hand side, and so we will be able to find out the lambda using the substitution of this point into the equation. Okay, so 1 plus -2 square is 4, -8 into -1 plus 8, -2 into -2 plus 4 plus 7 plus lambda into x square, which is actually lambda, and lambda into 4 and -4, basically lambda minus 4x is uh, plus 4 and plus 10xy. So sorry, plus 10 lambda y. So plus 10 lambda is minus of 20 lambda plus 8 lambda. Okay, let's solve it. This becomes plus 5, 13, 17, 17, and then 24. If I'm correct, calculating correctly, this becomes 5 lambda, 9 lambda, 17 lambda, minus 3 lambda. So lambda becomes 8. If lambda becomes 8, the equation changes. Let's calculate the equation now. So x square into, this can be rewritten as x square 1 plus lambda plus y square into 1 plus lambda again plus x into -8 minus 4 lambda plus y into -2 plus 10 lambda, and then 8 lambda plus 7 is equals to 0. Now let's put lambda as 8. So 9x square plus 9y square. Okay. So this equation, this option is cancelled. Now what is the difference between these two is of the y. So let's check y. So -2 plus 10 into 8, 80. So this will become plus. So plus option wins and A option should be your correct option. We can also check the remaining so that the D does not become the uh, correct option. A is the correct option. Understood?
Yes, sir.
Yeah. Now let's discuss the cases. So these are the conditions that we are going to discuss about when two circles touch or do not touch each other. So we are going to discuss about the position of different circles. And also we are going to talk about the number of common tangents. Okay, so what's going to be important for us is the two information, that is the distance between the center of 2 points and about the number of common tangents. So in this first case where we are seeing these two circles are not touching each other. The one circle is lying inside another circle. So here the distance between these two centers is definitely going to be greater or equal to the equal to the difference between the radii of these two, and there will be no common tangents. Means common tangent means the tangent which is tangent to the outer circle and tangent to the inner circle as well. So there can be no tangent drawn such so that uh, the same tangent can be tangent from both of those two circles. It is not happening. So there will be zero common tangents. Zero common tangent. And the distance between C1 and C2 is going to be more than or equal to the difference between the radii of two. Next case comes when two circles are touching each other internally at a single point. So this time the condition that C1, C2 is is basically R1 minus R2. Basically, if this is, let's say this is the radius R2 and the radius of the bigger circle is R1. This whole is R1 and this is R2. So the distance between those two circles is simply R1 minus R2. Okay, this point is clear. And how many common tangents? There can be one common tangent. Let me show how. This is the tangent to circle 1 and circle 2. This is the tangent to both of the circle. That's why we are calling it as a common tangent, which is 1 in number. Which is 1 in number. This is the common tangent. Clear?
Yes, sir.
These cases are important. If two circles intersect each other, so see, here there are two circles of different radii and they're intersecting each other like this. This time there will be two common tangents. How? This is one common tangent. This is one common tangent. And the another common tangent can be somewhat drawn here. So these two common tangents can be drawn when circles are intersecting in a way. And this is very important condition where the difference between the radii should be less than the distance between the C1 and C2, and the addition of R1 and R2 should be more than the distance between C1 and C2, because this is R1 and this is again R2. So see, the addition, if we'll take the addition, so it has to be greater than C1 and C2. Okay. The difference between these two is this only, which is of course less than C1 and C2. So that's how one logic from which we can understand this relation. You have to remember this. There are two common tangents. Clear?
Yes, sir.
Understood? Yeah. Nice. If the circles are touching externally, means the distance between C1 and C2 is simply R1 plus R2. How many common tangents? One common tangent can be made in this manner, and the other common tangent can be made in this manner. And there can be one more tangent, common tangent. Tell me, where should I draw it? This is also a tangent to both of the circles. Na? There can be three common tangents. Two things to remember in the diagram. Understood?
Yes, sir.
If the circle are not touching at any point, then simply the distance between both of the circles are more than the sum of R1 and R2. That's self-explanatory. Common tangents and this is the one. And one more common tangent like this. So how many common tangents are there? There are four common tangents. Important point. There are four common tangents. I think this is the maximum number of common tangents that can be there with two circles. And the distance between C1 and C2 will be greater than the sum of the radii. R1 and R2 are both positive entities. Understood?
Yes, sir.
Yeah. So that's a question. So these are equation of two circles given with us. And now we have to find out whether they are touching internally, externally, or nowhere. So this kind of question has been asked in NDA. Kind of question type. Okay. So for finding out the distance between the centers, what we need is the coordinate of both of the centers, and to relate the relation, we'll need radius 1 and radius 2. Okay, so the center here is -1 and -1. Okay, radius 1 square plus 1 square minus of 1. So radius is 1 for the first circle. Now let's discuss is this thing clear that how have I written the center and the radius from the basic general equation of circle?
Yes, sir.
Okay, then center for this is 2 and 6 by 2 is 3. Okay, radius 2 square plus 3 square minus minus plus, so 9 3 12, 12 plus 4 16, radius becomes 4. Okay, distance between C1 and C2, applying distance formula. So let me segregate the calculations. C1 and C2, applying distance formula. 2 minus minus 1. So 2 minus minus 1 whole square plus 3 minus minus 1 whole square. So this becomes 3 whole square, that is 9. 4 whole square, that is 16. That becomes 5. R1 and plus R2 becomes 4 plus 1, 5. So C1, C2 is equals to R1 and R1 plus R2. When this was happening, the distance between two centers is equals to the sum of R1 and R2. Which case is this? Try to remember and use your logic even. When this was happening, when the circle were touching itself, each other, intersecting each other, or not touching each other. If you're not able to remember, problem. See, when two circles were touching each other externally, then it was happening that R1 plus R2 was equal to the distance between C1 and C2. And how many common tangents were there? There were three common tangents. So the answer becomes B. The number of common tangents becomes 3. This can also be asked. Understood?
Yes, sir.
Look here also. They have compared the distance between C1, C2 and R1 plus R2. So this chapter is finished. Let's revise. This is the equation of a circle. If A and B are equal, and the general equation includes x square plus y square plus 2gx plus 2fy plus c is equals to 0, where the coefficient of x square and y square are 1. And the coefficient of xy is 0. Center of a circle is midpoint of the diameter and radius is half of the length of the diameter. Yes, we know it. And uh, needless to say that if this is a circle and this is a diameter, it is having coordinate x1, y1, and the other end of the diameter is this. And if this is a straight line, then the center is x1 plus x2 divided by 2 and y1 plus y2 divided by 2 because it's the midpoint. Understood?
Yes, sir.
Yeah. Let's find out the intercepts on axis. So this we have discussed earlier as well now. When the length of the intercepts made by circle with x-axis is 2 into square root of g square minus c, and with y-axis is 2 into f square minus c. And in this case, if f square has to be greater than c and g square has to be greater than c. If that is not the case, it means that the circle is not intercepting that particular axis that we are talking about. If g square uh, is less than c, then it means the circle is not touching the x-axis anywhere. These are important. Memorize. Point x1, y1 lies outside or inside the circle when s1. Okay, we already talked about it. When s is equals to 0, then the point is lying on the circle. When s is less than 0, the point is lying inside the circle. When s is more than 0, then the point is lying outside the circle. Next point comes for finding out the number of tangents. We have discussed it already. In general, two real tangents can be drawn from a point outside a circle. Okay, from a point, there can be two tangents drawn like this. Two tangents drawn. The point theta on the circle. Okay, so this is the parametric form. A line touches a circle if the length of the perpendicular from the line touches a circle means this line is tangent. When the length of the perpendicular from the center is equal to the radius. So when the distance between the line and the center is equals to radius, that means that it is a tangent. Next point. A line intersect a given circle at two distinct real points. If the length, a line intersects a given circle at two distinct points if the length of the perpendicular. Basically, when the distance is less than the r. And we have discussed about distance, which is c upon square root of 1 plus m square. So this is less than r. Then the line is intersecting the given circle at two distinct points. The line does not intersect a circle. The length of the perpendicular is greater. If radius is less than the distance, then the line is not intersecting. It is okay. Now the next point is here, and the next point is written. This is the same point, and this r is c upon 1 plus m squared this time. Next point. If circle is this touching the y-axis, then g square is equals to c. If the circle is touching the x-axis, That it means G square will be equal to C. If the circle is touching the y-axis, that means that F square will be C. And here we discussed about the length of intercepts. Means the circle is how much distance away from the x-axis, how much distance away from the y-axis. That was the intercept. Okay. The circle will be touching x-axis when g square is equals to c, and the circle will be touching y-axis when f square is equals to c. Okay. And the circle will touch both axes when g square is equals to f square. And in this case, c will be 0. Next point I have already explained. The last point is the diameter corresponding to a system of parallel chords